Modulation of signals is very important. There's three main reasons why we modulate. First reason is it makes transmission practical. It's got to do with the size of the antenna. We're just about to talk about it. It means you can use the spectrum wisely and you get around interference and propagation effects. Let's have a look first up at what I mean by saying it makes transmission practical. Light travels at 300,000 kilometres a second. 300,000 kilometres a second, that many metres per second. Let's pick a FM radio station. Let's talk about modulation of a FM signal. FM, 100 megahertz. Which means 100 million times a second, that peak of the wave is travelling past a point. That means the physical distance between two peaks, if it's travelling at 300,000 metres a second, and there's 300 million metres a second, and there's 100 million peaks. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The peaks are 3 metres apart. An aerial needs to be about 1/4 to 1/2 wavelength, even up to 1 wavelength long. So a 3 metre aerial is perfect to pick up FM radio signals in the bandwidth they transmit in Australia at. So if you can transmit a signal at 100 megahertz, well and good. Let's say if instead of 100 megahertz, you transmit sound just at the audible frequency, say 10,000 hertz. 300 million again, divided by 10,000. That's 30 kilometres. If you need to pick up a waveform that's travelling at 10,000 hertz, electromagnetic wave, you need an aerial that is 30 kilometres long. Good luck with that. We modulate so antennas are reasonably sized. Using the spectrum wisely is the same thing. As you know, you can pick up multiple FM radio bands. If everybody transmitted just straight speech at 10,000 hertz, then the whole world will be transmitting on one frequency. I don't know how you would actually interpret that at the other end. If you had 15 radio stations all broadcasting on the same channel, how would you demodulate it? It's fairly well impossible. Instead, we use the spectrum wisely and we basically chop it up into pieces. So if you look at Sydney radio stations, let's go. There's one at 101.7, there's another one at 102.5, there's one at 103.3, 104.1, 104.9, 105.7, 6.5, 107.3. They are the Sydney commercial radio bands. The typical FM radio band in Australia, it is travelling at around about 200 megahertz. Sorry, 200 kilohertz, plus or minus. So that means 104.9 works between about 104.7 up to 105.1. So it's transmitting in a tiny, tiny radio band. Up the coast in Newcastle, down the coast in Wollongong, the transmitters are 105.3, 104.5, halfway between that 0.8 difference in the radio bands. We modulate so we can use the spectrum wisely and we can allocate frequencies that don't overlap and interfere with each other. And the third reason why we modulate, we'll talk about when we get to AM and FM. You can choose a modulation mode that minimises interference.